future is space travel. It meets the human need to discover and fly, and it can also provide our species with new homes in the years and decades ahead, as the Earth becomes increasingly crowded. Hi everybody! In this video, we will talk about everything you need to know about space travel. Thumbs up for the video. If you're new here, welcome. Be sure to subscribe to the channel and hit the bell icon to be updated whenever a new video is uploaded. To start, when did we first begin to explore space? A German V-2 rocket, deployed on a test flight in 1942, was the first human-made target to reach orbit. Even though it was unmanned, it attained a height of 189 kilometers, 117 miles. Former Nazi rocket scientists were later employed by both America and Russia and were influential in the development of intercontinental ballistic missiles, ICBMs, rockets capable of transporting nuclear warheads from one side of the globe to the other. These super missiles served as the foundation for all post-war superpower space programs. Russia was the first to enter Earth orbit when it launched Sputnik 1, an unmanned spacecraft, in October 1957, followed a month later by Sputnik 2, which carried the dog Laika, the first living animal in space. In January 1958, the United States launched its first unmanned spacecraft, Explorer 1, into space. On both sides of the Atlantic, a slew of robotic spaceflights followed before Russian cosmonaut Yuri Gagarin piloted Vostok 1 into orbit on April 12, 1961, to become the first human in space. The space race officially began after that, with NASA's Apollo mission resulting in Neil Armstrong and Buzz Aldrin becoming the first humans to walk on the moon. Space travel is very important since it has some practical reasons as well, such as mining asteroids. Like obtaining materials that are highly rare on Earth. The massive supply of the chemical isotope helium-3 believed to be tucked away in the soil on the moon's surface is one example. This isotope could be used as a catalyst for possible nuclear fusion plants. Helium-3, unlike other fusion fuels, does not emit dangerous neutron radiation that is difficult to contain. China's Chang'e 4 mission launched a new space race to conquer the moon in 2019, signaling their intention to create a permanent lunar base, while NASA's Artemis mission aims to build a space station named the Lunar Orbital Platform Gateway, which will serve as a platform to shuttle astronauts to the moon's surface. So, several space missions claim that they aim to advance science's frontiers. However, even the advancement of spaceflight technology will result in unexpected but useful, spin-off, developments with a variety of practical applications. Memory foam mattresses, artificial cores, and the lubricant spray WD-40 are only a few examples of notable NASA spin-offs. There will undoubtedly be even more. Space exploration also inspires awe, reminding us that there are challenges bigger than our mundane world and its petty quarrels, and it undoubtedly serves to encourage a new generation of young scientists. It's also a form of insurance. We're all too aware that natural disasters will and do occur, such as climate change and the massive meteor that slammed into the Earth 65 million years ago, causing the dinosaurs to become extinct. The moral of the story is that we should never put all our eggs in one basket. A safe space program, on the other hand, offers humanity a way out, as does the ability to fly to other planets. There are several challenges while traveling to space. Space is not a friendly place. Your spacecraft can protect you from the vacuum, but watch out for the meteoroids. It's not easy to get to space. The vast distances between destinations make travel difficult until we arrive. Astronauts seem to be flying, but they are still sinking. While floating weightlessly around a space station seems to be a lot of fun, astronauts aren't there to have a good time. They've come to work. Getting into orbit requires a speed of about 28,000 kilometers per hour, 17,000 miles per hour, or 22 times the speed of sound. When things go south at that speed, it's rarely good news. Then there's the rising cloud of space junk in Earth's orbit, which includes obsolete rockets, abandoned rocket stages, and other debris, all of which is traveling at incredible speeds. A 5-gram bolt traveling at orbital speed has the same amount of energy as a 200-pound weight falling from an 18-story structure. Getting to space is just the beginning of the threat. If the extreme temperatures don't get you, the radiation will. The only danger while you're there is cancer-causing radiation. Due to the planet's atmosphere and protective magnetic field, a single day in space is equal to a year's worth of radiation on Earth. When you consider the ice-cold airless vacuum, the need to hold all your food and water, as well as the impact of long-term weightlessness on bone structure, the brain, and muscle condition, especially the heart, it's apparent that going into space isn't for the faint of heart. We need ways to shield our astronauts if we want to fly across space. The particles found in space have the potential to disrupt our technology by tripping onboard electronics. Dr. Collado Vega says, "It's very similar to what we're doing today. We're constantly developing and testing new models to predict space weather. And we're constantly seeking new data to refine those models. It's not exactly what you see in the movies when it comes to space travel." 2. Slingshot, from planet to planet, or moon, through the solar system, complicated equations involving inertia and gravity, literally, rocket science, are needed. The 1970s Voyager mission took advantage of the unusual conjunction of Jupiter, Saturn, Uranus, and Neptune to reduce travel time by nearly 20 years. It is also risky to travel across space. More than 20 astronauts have died while performing their duties. Dennis Tito, a U.S. businessman, was the first self-funded orbit traveler, spending $20 million for a week on board the International Space Station, ISS, in 2001. Space tourism is divided into 3 categories: terrestrial, suborbital, and lunar space tourism. Only the Russian Space Agency has conducted orbital space tourism to date. Work on designing suborbital space tourism vehicles is also continuing. Aerospace firms such as Blue Origin and Virgin Galactic are doing this. In addition, in 2018, SpaceX, an aerospace company, revealed that the Starship will be used to send space tourists, including Yusaku Maezawa, on a free return trajectory around the Moon. Virgin Galactic has long promised to send customers on brief suborbital flights into space, where they can witness rocket acceleration and several minutes of weightlessness before gliding down to Earth on a runway landing for $250,000, £190,000. The company revealed the completed cabin in its Spaceship Two spacecraft in late July 2020, indicating that commercial spaceflights could begin soon. Meanwhile, Elon Musk's SpaceX, which is the first private enterprise to send a human crew to Earth orbit aboard the Crew Dragon in May 2020, expects to charge $35,000 per night for stays on the ISS. SpaceX is currently prototyping the massive Starship spacecraft, which can transport 100 passengers from Earth to as far as Mars for about $20,000 per individual. Musk claimed in January that by 2050, he wanted to see 1,000 Starships in service. We know that keeping a close eye on the world surrounding us is critical to maintaining safe passage, whether it was the seas ancient ships sailed through or space we would one day fly through. This is it for today's video. I hope you enjoyed this video. Please click the like button if you enjoyed this video. Thank you for watching, and I look forward to seeing you in the next video. Don't forget to subscribe to this channel for more updates.